In previous videos, we have investigated diffraction of light by single-edged obstacle with some variations on the edge parameters. Now we'll do the investigation with double-edged obstacles, which can be divided into two types. First is the outer obstacle, where the light beam is streamed from outer sides. This is widely known as single-slit diffraction. I think the word single here can be misleading, since it implies something that is thought to be the simplest form of diffraction. Here we start with diffraction by a metal sheet, and see that the diffracted and reflected light on the screen doesn't produce interference pattern. Let's introduce another metal sheet right next to the first one. When the second sheet is exposed to the laser beam, it also reflects and diffracts the light, hence becomes additional light source for the light pattern on the screen. Now we can see an interference pattern of those light sources, which is indicated by alternating bright and dark spots on the screen. Most textbooks explain that they are produced by constructive and destructive interference respectively. This feature wasn't found only single-edged obstacle as shown in previous videos. The width of bright spots on the screen depends on the width of gap between the sheets. The narrower the gap, the wider bright spots will be. Note that central bright spot is twice as wide as the others. The other type of double-edged obstacle is inner obstacle, where the obstacle lies between those two edges, such as diffraction by a thin wire. The thinner the wire, the wider bright spots will be. Just like the outer type, the central bright spot is also wide as the other bright spots. This time, we can also find that central bright spot is brighter than before, and a trace of an obstructed light beam is found on the screen. We can find many sources explain the occurrence of light and dark bands in a single slit diffraction by incorporating Huygens principle with infinite number of wavelets. But interestingly, they don't use the same method to explain the similar pattern produced by thin wire diffraction. Some sources try to explain this by combining Huygens principle and Babinet's principle. Basically, it states that if we combine the light pattern produced by an obstacle and its complementary obstacle, the result is the original light pattern without obstacle. In other words, the unobstructed light spot inner obstacle will produce the same diffraction pattern as outer obstacle with the same width, but their phase is shifted by 180 degrees.